I posted an older video last week, and I'm going to go over that again, but I'm going to go over the part that gives students the most trouble. So I'm going to pick up right here, and if you haven't
I have a
viewed,
question. What chapter is that?
um,
Just so I can get the slides.
it should be in the extra lab schedule,
Okay, perfect. Thank you.
but it's chapter 21.
Thank you.
Okay, um, now where we are is this first part is very straightforward, but this is where it gets tricky. That's why I wanted to review this part. Okay. Monosaccharides and disaccharides um, exist predominantly as a cyclic hemiacetal and hemiketal. And so the first thing you need to do when you're looking at one of these guys is where's the anomeric carbon? And that would be right here where the OCO is. OCO. OCO. So then this is going to be the anomeric carbon here. And that's the one that can open up to an aldehyde. Now this OH here on the anomeric carbon can be up or down. And I'll show you that in a little while. If it's up, it's a beta version. If it's down, it's alpha version. And
Hello.
yeah,
Yeah, it's cold.
I'm sorry, what? I could have swore you said eyes are closed. Okay. And again, on these anomeric carbons, the OH can go up or down. So for example, this is a 1, 2, 3, 4, 5 carbon sugar. And all the natural sugars are D form. We're going to find the, when we get to the next unit, the alpha, the amino acids are all beta form. Okay, and the reason there's a D and an L form of sugars is because of the chiral carbon. Now that was covered earlier slides, from the last lecture I gave. So, okay, let's go on here. All right, now this is where it kind of gets tricky. Okay, so here we have glucose down here, and it's in the beta form because the OH here is going up. This is the anomeric carbon because we have OCO. OCO. So this is the alpha version with the hydroxyl group going down. Now, both of these, alpha and beta, are common. The reason why they're common, probably 50-50 or close to that, is because they can open up. It opens up at the anomeric carbon to go from a hemiacetal to a aldehyde and a alcohol over here. So aldehyde plus alcohol, when they come together, they form a hemiacetal. Hemiacetal over here and over here. And when they open up and expose the aldehyde, aldehydes, as you know, are easily oxidized. So they're very susceptible when they open up. Now, remember in the aldehyde and ketone chapter, we talked about the aldehydes are easily oxidized. And one of the tests for aldehydes is the Benedict's test. So with sugars are also susceptible to the Benedict's test because of this opening up to an aldehyde. Now, we have, one other thing, numbering. Numbering starts at the anomeric carbon as carbon number 1. Normally, if we have an aldose, like glucose or galactose, it's usually carbon number 1. Fructose opens up to a ketone. That's why it's called a ketose. Opens up to ketose, and it's the anomeric carbon there is on carbon number 2. We'll see that in the future slides here. So anyway, it goes around the ring counterclockwise, all the way up to the top here, and yet carbon number 6. Now, oh, geez, something here I forgot. Here. Now, this ring can have 6 members in it or 5-member rings. Okay, so this is a 6-member ring, so it's a pyranose. The 5-membered ring, still 6 carbons long, but 5 members of the ring. It's called a pyranose. And this is going to be where the hydroxyl group attaches. And that's where the anomeric carbon will be. Okay, so this is what fructose looks like. 6 carbons. When it opens up to a ketone. So that's why these are called ketoses. Okay, and this is the anomeric carbon here. So we have OCO, OCO. And it's a hemiketal. Now, when this opens up to a ketone, in this open, it exposes a ketone. The Benedict's test is for aldehydes, except there were 2 exceptions. If there was an adjacent OH group or an adjacent carbonyl group, that would give a positive Benedict's test as well. The reason for that is these can go back and forth between a ketone and a aldehyde, back and forth in a resonance structure. And that's why it gives a positive test for Benedict's. When it's in the aldehyde version, it tests positive. When it's in the ketone version, it doesn't test negative, but it goes back and forth, back and forth. In fact, if you remember from 305, something called Le Chatelier's principle on equilibriums, what happens is the Benedict's test is a force moving the equilibrium to the aldehyde side. And that's why the aldehyde um, uh, gives that positive test for the Benedict's test. Okay, so you're going to be learning some structures in this chapter. And one of the structures is glucose. A very close relative to that is galactose, and then fructose. Now these numbers down here got shifted. Let me just redo the numbers here. This is carbon 1, 2. And they're numbered up here as well. Okay, so again, fructose falls into those two exceptions where we have an hydroxyl group next to the ketone carbonyl. So it will go back and forth between a ketone and an aldehyde. Okay, the way biochemists write structures for carbohydrates is they always put the anomeric carbon on the right. Now we're going to see when we talk about sucrose, most biological textbooks flip that around. They don't stick to the standard of putting the anomeric carbon on the right. Well, I'll show you when it comes up, but it's the standard in our class is like the IUPAC standard. Anomeric carbons go on the right. Now, if there is a hemiacetal in the sugar, whether it's a single sugar or a disaccharide or a oligosaccharide, it will open up somewhere. Usually it's on the right-hand side if you lay the thing out. Now, for example, Benedict's solution, because it has comes from copper +2 or cupric ion, it's blue. And these are two glucoses. And if these are an aldose or a fructose, they will turn the copper +2 to copper +1 in these shades of kind of rusty color. And this one's kind of a rusty color that's been sitting out in the weather for 6 or 7 years. And this happens, you're going to find when we do this test in lab, this reaction happens very, very fast within a couple seconds. Now we're going to find in the next unit, unit 3, about esters. And an ester is an acid plus an alcohol. So carbohydrates are polyols, meaning they have lots and lots of alcohols on them. So the least restrictive of them all, alcohol-wise, is the top one on both fructose and glucose. So they can form phosphate groups. that are esters. So this is an ester here. And together, these form an ester. It's an E that you can't read. Okay, same over here. This would be the acid, alcohol. So during glycolysis, it's the first stage of carbohydrate metabolism. The glucose is phosphorylated on carbon number 6. So we end up with glucose 6 phosphate. Step number 3, fructose comes in down here. Step number 3 of glycolysis. Glycolysis is the major energy supplier for simple organisms like yeast. And that's how alcohol is made, using the glycolysis reaction. Okay. Now, the interesting thing about this here is when this is a hemiacetal over here. We have oops, OCO, OCO. So when you add an alcohol to a hemiacetal, it goes to the full acetal. So this is an acetal over here in the middle. This is a hemiacetal on the left. And you can do our little test. So we have OCO. That's yes. We have a hydrogen. Yes. We have an OH. Yes. So that means hemiacetal. So when we have a hemiacetal and an alcohol, they'll form a full acetal. Well, in carbohydrates, the alcohol comes from carbon number 4 on another glucose. So this is the alcohol here, the second alcohol added to the hemiacetal here. And then what they form is a CO, and there are 2 here, OCOs. They're not the same though, because this is on the right. This forms a hemi. And this OCO down here, so we've got an OCO, we've got a hydrogen, that's a yes, and no OH. That means it's not a hemiacetal, it's a full-blown acetal. So acetals don't open up. Hemiacetals do. So the question is this a reducing sugar? So if a hemiacetal is present, it opens up to an aldehyde, meaning it's a reducing sugar. This has one of each. It has a hemi here on the right and a full acetal on the left. So this part doesn't open up. And this part opens up. Now, this is where this subunit gets tricky, are these reactions now. This OH group on the on this carbon here can go up or down, alpha, beta. If it goes up, it's a beta version. And this says we're linking a beta anomeric carbon, number 1, to a OH group on carbon number 4 on the right-hand side, glucose. So this is a beta 1,4 glycosidic linkage. Now these linkages are very important because if, for example, if this was galactose here instead of glucose, this would be lactose. So this here is galactose. This is glucose. They differ in carbon number 4's direction of the OH group. If it's up, it's galactose. If it goes down, it's glucose. Notice down here, we have the OH going down. That's why it's glucose. Everything else is exactly the same. Sweetness-wise, they're very similar. Galactose is biochemically important in your body, particularly when you're looking at neurology. Excuse me. But anyway, that's what lactose looks like. That's one of the disaccharides you're going to have to know is galactose and glucose form lactose. Notice there's lactose built into galactose. Okay, and it is a reducing sugar because of this guy over here being a hemiacetal. So lactose is a reducing sugar. That means it'll give a positive Benedict's test. Okay, it says glycosides are not reducing sugars. They are reducing sugars if the right-handmost sugar is a hemiacetal. Okay. There are two real important 5-carbon furanoses you need to know. Ribose and deoxyribose. Deoxyribose has no hydroxyl group on carbon number 2. So normally you would say, I'm not going to put the D in because everything we can do in this class is going to be D for carbs. Beta 2 deoxyribose. And they always leave off the 2, but it could be any of them and be a deoxyribose. The biochemically the most important one is on the carbon number 2. Now, frequently you will see on food labels dextrose. That's a fancy way of saying there is sugar in there, and the sugar is called glucose. And because you look at the label and say, oh, there's no sugar and there's no sucrose or fructose. It's got dextrose in it though. And it can be in alpha or beta form. Downs alpha, ups beta. And this is the closed form. Now, normally when we write glucose, we write it in the closed form because that's more stable than when it's opened up. And when it opens up, it exposes the aldehyde, which is very susceptible to oxidation. So the closed one is not susceptible to oxidation until it opens up. Hence, it's more stable. Now, glucose is kind of what I call the common denominator in monosaccharides. Frequently, um, because carbohydrate metabolism starts with glucose or fructose, three layers, three reactions down, it always goes to glucose. Now, if you're fasting and you deprive yourself of carbs, one of the things that our brain needs is glucose. It'll pass through the blood-brain barrier, and but that's it though. Some of the other stuff won't pass through. So that's why it always reverts to the common glucose. So when we deplete all of our glucose in our blood, and then we start working on glycogen. Glycogen, we'll see in a little while, are just a polymer, a biopolymer of glucose molecules strung together. So we have reactions that will take that glycogen apart into glucose. So we're back to glucose. So when all the glycogen is used up, then we turn to fat. And then we have reactions that will convert the fat again back to glucose. When we use up all our fat reserves and we go to muscles. Proteins. Proteins can be converted to, it always goes back to glucose. Glucose, and then starts the glycolysis cycle. Okay, so definitely need to know this one. You're going to see this one a lot. Galactose, as I was showing you before, this OH just goes up on carbon number 4. And you have alpha and beta versions of it as well. Fructose is a ketohexose because it opens up to a ketone when it does open up. Carbon number 2 is the anomeric carbon for fructose. Okay. So I kind of went over this already. Disaccharides are two monosaccharides linked together by an acetal or a ketal glycosylic linkages. So we have okay, so we take glucose, the hemiacetal is on the right side. We're going to be using carbon number 4's hydroxyl group from the glucose as the alcohol. And those are going to form a linkage, let me get this bigger. Now the glucose can be up for alpha, down for beta, and that has to be reflected in the description of the linkage. Also is descriptive of what carbons are involved. Now, I like to write this differently than this is. I like to write this like this, because this implies that the carbon number 4 can be alpha or beta, and it's not. If it's anything but going down, it's not glucose. But going up, it's galactose. So it's always a non-option on carbon number 4. Okay. And this is one of the disaccharides you're going to need to know. Maltose, two glucoses, and it's only alpha 1,4 glycosylic linkage. If it's a beta 1,4, it's not maltose. And I can't stress that strongly enough. You've got to have the correct linkage for anything other than a monosaccharide. If it's a disaccharide, a oligosaccharide, or polysaccharide, the linkage is horrendously important. For example, on polysaccharides, there is starch, which uses an alpha 1,4 linkage, and there is cellulose, which is a beta 1,4 linkage. That's the only difference between starch and cellulose. And our bodies can't digest directly through carbohydrate metabolism the cellulose, but our microfauna, or gut bacteria can. So it's a prebiotic. Okay, so anyway, so the question now is, we've got a full acetal here, and we have a hemiacetal here. So maltose is a reducing sugar. So so here it is here. O, C, O. And we've got an H here. And then we have no OH. So it's not a hemming, it's just a plain acetal. Well, here on the right side, and I'm repeating this because it's tricky for students. That's why I'm just doing this over and over again. Okay, so over here we have on the right hand mono, we've got OCO, we've got an OH, and we have an H. There's an H right here. So this is a hemi. Acetal. So this can open up. Opens up to an aldehyde. And if we look at the Benedict's test now, so now we have an aldehyde, and we've got, make this smaller, got an aldehyde here that's susceptible to being oxidized. It's going to be oxidized by the copper. So the copper, now goes over to copper, from copper 2 to copper 1. So that's being reduced. That's why it's called a reducing sugar. And the aldehyde is being oxidized to the, and this is in a basic or alkaline solution, to the salt. So that's what it looks like. Okay, so you need to know this reaction. This is the most complicated one we're going to get to, and it's plenty complicated. So let's do one more here. Let's do, so I'm going to be asking questions like on the test. I'll show you a molecule like this, and I'll say, first of all, what is it? So this would be a, actually, I would show you this molecule. I would say, first of all, what is it? Okay, you look at it and you go, oh, glucose, glucose. That means this is maltose. Which maltose is it? Because this OH over here in the hemiacetal is going down, it's an My Google is answering my maltose question. Okay, so the OH is going down here, so it's an alpha maltose. Okay, question number one. Okay, I ask you, what is it? Second is it a reducing sugar? And then your question would then focus on this one here, and then you analyze this glycosylic link, this anomeric carbon OCO, and you analyze it to it is a hemiacetal. So the answer is yes, and I'll say why, and you give this as an example. And then the next thing is I'll ask you is the linkage between the two glucose groups, and you're going to answer this. This is going down, so it's an alpha carbon number 1 hooking up to carbon number 4. So it's an alpha 1,4 glycosidic linkage. That would be a typical test question. Okay. This just described everything I just said. Okay. The reason why this is called maltose, it was first discovered in beer, in making beer. And the other disaccharide, there are three disaccharides you need to know. This is the second one. The only difference between, there are two differences between maltose and lactose. One is the linkage is different. Okay, with lactose, the linkage is a oh, it's not listed on here. The linkage is a beta because the O here is going up. So it's going to be a beta 1 for glycosylic linkage. And the beta's got a little tail on it too. Okay, so this is glucose on the right, galactose on the left. And it is a reducing sugar because it's got a hemiacetal present. Again, look for the hemiacetal. Hemiacetal is present. Yes, it's a reducing sugar. Now, sucrose. Most of the time when you see sucrose in biology books, the fructose here on the bottom here is not on the bottom, it's flipped left to right. So the anomeric carbon is on the left rather than the right. So they can put this in a stream. So what it looks like is this rather than this. But see, the anomeric carbons, here's the correct way, here's the wrong way. But they do this in books all the time. It just upsets me. Now let's look at the linkage here. Because we got the linkage is through the anomeric carbons. So we've got this O is going down. So that's for this one up here, it's an alpha carbon number 1, alpha 1. Here, the anomeric carbon on the fructose is on carbon number 2, and it's going up. So that's a beta 2. So this is an alpha 1 beta 2 glycosylic linkage. Question now is, this is fructose on the bottom. And it's beta fructose. Has to be beta. Otherwise, it's not sucrose. The glucose is alpha glucose. It has to be alpha or it won't be sucrose. These molecules are very picky about this linkage. Okay, so the question is on the test would be identify it, and you'd say, oh, that's sucrose. And it's neither an alpha or beta sucrose because there's no hemiacetal. So the only, let's see, here is the OCO, and here's the other one. Back, let's do that in another color here. So we have two OCOs, just like the other disaccharides, OCOs. This, though, neither one of these has an OH group. So it can't be a hemi. So what happens is, if we analyze this top one, okay, so the top one now, it's going to be OCO, no OH, and there is an H. So the top glucose, now this is for the glucose now, is a acetal. And let's look at the bottom one. We have OCO right here. And we have no hydrogen, it's carbon there. And we have no OH, so this is a ketal. So sucrose has a ketal and an acetal, no hemiacetal. Hence, it's not a reducing sugar. Okay, let's see here. I think of anything else. What's interesting is there's something called invert sugar. So when you get sugar from honey, it's not sucrose. It's a mixture of glucose and fructose. That's why they call it an invert sugar. That's what this was pointing out right here. So if you have an invert sugar, question is it a reducing sugar? And the answer is yes. Invert sugars have these two separated. So each one of these separated do have a hemiacetal present. Hence, it'll give a positive Benedict's test. Hence, it is a reducing sugar. Sucrose, which comes from sugar beets and sugar cane, is attached with no hemiacetal. So it's the disaccharide coming from sugar cane and sugar beets is not a reducing sugar. No hemiacetal. And I don't know why honey is separate, but it is. Okay, the third class of carbs you're going to have to know are called oligosaccharides. And these are extremely important. They they're basically sucrose with galactose tacked on the top. And the other one, this is called raffinose, the other one is saccharose. It's got two galactoses tacked onto the top. Okay, yeah, this was an error. It's not a beta 1,6, it's an alpha 1,6. Okay, now that the interesting thing about this is um, it's really important in breast milk, raffinose. And what it is, when a baby ingests raffinose, they don't take this apart. It's used as a prebiotic for the um, probiotic bacteria and to eat. So if you feed your baby formula and it doesn't contain raffinose, um, do not give it to your baby because it's just pure sugar water. Um, so just look on the package, raffinose, yes or no. So it's not hard, it's just big. And it appears like, so it's got the same linkages, alpha 1, beta 2 here. And this is an alpha 1,6 because this is attaching to carbon number 6 here, hence the 6 here. And then the other oligosaccharide is stachanose. This just has 2 lactoses up here. Now there's a whole bunch of oligosaccharides. These are the most common. So we have a full acetal here, full ketal, full acetyl. So this has no hemiacetals again, hence it's not a reducing sugar. Now this is interesting because this is a major cause of flatulence when you eat beans. That's why the process to make beans and eliminate flatulence is to let them soak overnight. We're talking about starting with dry beans. You let them soak overnight and you dump the water left over because that's where all the stachanose is. I'm hearing sounds that one of my dog is barfing, but I guess they're not. So it's also a prebiotic for babies. And in fact, if you take Beano to reduce gas, it converts all this takes the galactose from the 2 galactoses from sucrose down below. This is sucrose down here. So what Beano does, it hydrolyzes right here and gives you plain old sucrose and galactose. But if you soak your beans overnight and then throw out the wash water, saccharose goes with that. And a lot of people keep that water because it says it adds flavor, but then you are going to have the stachanose in that water. Now, this is a very common oligosaccharide, but it's a special kind. Instead of having sucrose, it's a combination of 2 fructoses together. And it is, this here varies in number. It can be from 5 up to 10. So these now, so this is an alpha 1,6 up here, attaching to the fructoses carbon 6. These are betas to beta, because the OH goes up in each one of them. And notice right here, we have an OCO. That means that can open up to the fructose, which, because it has an OH adjacent to it, can then, through resonance, can go over and create an aldehyde out of that. Hence, it's positive Benedict's test. Hence, it's reducing sugar. And this, oops, let me do this in red. That's the part that gives you the reducing sugar. So let's do a Benedict's test. We have three sugars here. Maltose, remember, is a reducing sugar because it has a hemiacetal on the right-hand side, glucose. Sucrose has no hemiacetals. And this other one is lactose. And lactose is a reducing sugar because it's got a hemiacetal on the right side. So we should get positive, negative, positive tests. We do Benedict's test, positive, negative, positive tests. So reducing sugar, non-reducing sugar. Okay. Now you need to know three polysaccharides, really two. Okay, excuse me. I'm still not over my medical problem. So I didn't sleep very well last night. Hence the coffee. Okay. Starch. Everyone's heard of starch. What it is, it's a series of glucoses all linked together. And people use it to form thickened solutions. That happens because the OH groups, hydroxyl groups, can form a hydration with water. And that thickens them up. Okay, all right. So it's a polymer, a biopolymer consisting of glucose units with an alpha 1,4 linkage. Alpha 1,4 linkage. Now the question is, and with no branching, that's another thing. We're gonna be looking at glycogen in a minute, which has branching. Now the sugar enzyme is amylose that breaks this apart. Okay, so this is branching, and it branches on carbon number 6. Okay, so this has two sets of linkages. There's an alpha 1,4 and an alpha 1,6. And these are all alpha 1,4s. Okay, and this is what glycogen looks like. It's branched. Now, one test for presence of starch is adding an iodine solution. What happens is it forms this dark, almost black coal. Very strong test. Okay. let's see, I'm gonna go back here and okay, there are two names that are very similar. There's amylase and amylose. ASE is commonly used with enzymes. So amylase is the enzyme that breaks apart the starch. The name of the starch, the non-branching starch, is amylose. Amylpectin is the branched version. Glycogen is very similar to amylpectin, except it's the only carbohydrate that mammals can make. So all these little yellow dots are glucose molecules, and the linkage is an alpha-1,4 and an alpha-1,6. So this is the first source when we run out of blood sugar. This is the first source our bodies go to, is to find glycogen. And there's a whole bunch of negative and positive feedback pathways to do that. And what happens is it will hydrolyze, meaning that it starts to break up the glycogen into individual glucoses. When that runs out, then we go to fat storage. When that runs out, we go to protein storage. Okay. The other polymer is cellulose. And again, it's made up of glucose units, but they're beta 1,4s. And it's dietary fiber, which is good if you're diabetic because it gives you satiation or fullness in your stomach, so you don't want to eat anymore. It also is a prebiotic for your gut bacteria. So that's the only difference between starch and cellulose is the linkage. Now, a trick question that I've been known to ask is these polymers, the amylpectin, amylose, cellulose, are these reducing sugars? And if everyone says, well, no, because these are all acetals. But there's one that is not. That's on the very end. If we keep going here, at the very end, there is a hemiacetal. So this is a weak reducing sugar. Because this could be 1,000 glucoses, but only one of them has a hemiacetal. That's the one at the very end. I guess we're done. Now, this, in my opinion, is the trickiest chapter we've come to yet. Just because it's not, the reactions are all we covered with aldehydes and ketones, but the structures are really complex. And that's what gives students problems is the structures. Now, this test, you can have a 3x5 card if you like. You don't have to have one. And there's a lot of information to fit on that little 3x5 card. And then both sides, 3x5 card. Okay, what do you guys think?
Confused.
Definitely gonna need some review. Let it sink in, I guess.
Theoretically, today was a review because Wednesday's lecture, I used an old version of this. But yeah, I need to revise I'm going to stop sharing here for a second. I'm going to go over to Canvas. So right now, this test is on Monday the 13th. So we have Wednesday to review, and we have next week to review, and then we'll have our test. So we'll have lots of review here. And this test will be on Monday the 13th. Now, it will also be available on Wednesday. So I'll do the same as last time. Now I'm gonna last time I had the test available on Monday for those who could not make it for Wednesday. So you can take it on either day, Monday or Tuesday, or Monday or Wednesday. And I'll be there earlier than 3, but I know one person had a work deal. She couldn't be there before 3. So I'll be there as long as anyone needs it. So you can have more than hour and a half, 2 hours for this test. If you need it, of course. Okay, so any questions about these guys?
I was just wondering if the test scores from the first test will be put in before we take the second.
Yes.
Okay.
My medical condition, I have irritable bowel syndrome that flares up every now and then. And I can't afford to be away from my bathroom. That's the problem. But I think I've turned the corner now. That's why I'm going to lab today. But I'll be working on that tonight and tomorrow. So you'll have it in for sure. Even though I have to get up at 5 o'clock in the morning tomorrow. I usually do anyway because of a certain dog. I'll get it done by tomorrow at the very latest.
Okay, thank you.
And normally I'm quicker on this. I just apologize. IBS is awful. It really is. And it strikes at stupid times, and you can't predict why was it the source of food I was eating? Were my leftovers too old? Was this food poisoning from when I haven't been out to a restaurant lately, but was it something like that? Who knows? It's oh. So if any of you are suffering from that, it's my condolences. It's not nice. And it can, it can be just really uncomfortable, give you stomach cramps, or you can have diarrhea, or you can have constipation. Just any of those are all thrown under IBS. Awful. Okay, so this week we're doing a steam distillation of oranges, and both green and orange. And then next week we're doing soap using the extract from the this week's lab with some coloring, and I have molds, so you can choose a star mold or all these different molds to pour your soap in before it hardens. And then you can take it home at the end of the semester, or if you take it home sooner than that, don't use it till the end of the semester because the reaction is very slow. What we're making is ivory soap, also known as lye soap. Lye soap reacts, the lye, sodium hydroxide, reacts with the triglyceride, which I'll talk about in Unit 3, which is an ester, and it breaks apart the ester, and the broken apart ester is what is soap. So the problem is the reaction goes really fast, and then it slows down to a snail's pace. And you got to use up all the lye though before you can use it. Otherwise, it would be uncomfortable to use. That's why don't use it till the end of the semester. But you can take it home sooner if you want, though. And we'll make enough for everyone. So everyone really likes that lab. It's it's kind of a macro lab with big beakers, and we're stirring this stuff, and it's pretty cool. Okay, does anyone have any questions about the schedule? Okay.
have a question towards the people that didn't went to lab last Wednesday. Where do we turn in our lab?
On the lab.
Last Wednesdays? Because we weren't in class.
Yeah, I posted a data table.
Okay, but do we turn it in
Did you read?
Canvas or like we turn it in or on the next lab?
Just use the data in it to fill out your data tables.
Okay, you don't have to grade it or anything.
I'm sorry, what was the last part?
Do you have to grade it or anything to turn it in?
Yeah, you've got think of it as you were doing the lab, and you generated
Okay.
the data on there. So you have to do
Oh.
conclusion, post lab questions, all that stuff.
Professor,
Okay.
I think she's asking, are we taking
Yeah.
pictures and uploading it into a module that you're going to grade on through Canvas, or when we show up on our lab day on Wednesday, we show you our composition book in person?
You're going to treat it like a regular lab. So scan it, put it in your lab notebook, scan it, and upload it to the assignment.
Oh, okay, perfect. Thank you.
Professor, just confirming you don't have to give the 2 signatures. We can just upload.
Yeah, because I wasn't there and you weren't there, so no, you don't have to worry about the signatures this time. And I know all you guys cleaned up really well, and you did all your pre-labs. I know, so I already know all that. So don't worry about the signatures. If you like it, I can sign it off on Wednesday because you're gonna have your lab books there anyway. So if you'd like me to sign off on it, I'd be glad to do that. It's not necessary though, what I'm saying.
And then where do we upload it? Like on Canvas, is there an assignment topic for it? Or
Yeah, let me jump over to Canvas here. Um, should be Lab 6. No, that's sunscreen.
Professor, isn't it Wet Lab 5 on alcohols?
Yeah, did I run by it?
Yeah, it's right above soap, so go a little bit more up. And it should be Wet Lab 10 soap making and then Wet Lab 5 alcohols.
Yeah, this is it here. So when you click on that, it'll prompt you for a file name, just like we've been doing.
okay, thank you.
While I'm on this page, if you're going to tie dye your lab coat, take a picture of it and click on this, and you'll get your 10 points. And topic project, you can do that anytime before October 20th. And there's one other one I wanted to mention. Yeah, test corrections for test 1. If you did those, click on this and scan your test, your old test with the corrections on it. And then I'll apply this when I grade this test question corrections. I'll then go to your test and change the score appropriately. Okay? Now make sure you get your waiver and your contract in, because you can get lab credit without turning in both of these. And you can't pass the class without passing lab. So, and these are super easy. And I can help you on Wednesday or today if you have questions on this.
And you said the test corrections is only for the first test?
Yeah.
Okay.
And then we never had a test for me. I just felt we've never had a test for me how I ask questions and all that stuff. That's why I allow it. However, it depends on how test 2 goes. If everyone is challenged with test 2, I may allow test corrections on that one as well. So I'll make an announcement and I'll put another assignment up. In fact, we should change this to test 1 corrections. Okay, any more questions? Let's see. Okay, all the chat stuff we've gone through. So whenever you're on, let's see, who's Kaylee? This is your dog, right? Do
Yeah, that's my dog.
you ever have embarrassing moments when you're on Zoom and your dog is throwing up or anything like that?
Throwing up? I can't say I have. I have 3 dogs. They're all pretty quiet.
I have 3 dogs also. I have 2 Yorkies and a poodle mix. Well, a poodle mix he's a really old guy. He's pushing 16. And so he has these dry heaves. So it sounds like he's throwing up, but nothing ever comes out. Ever since I got him, he's had those. So I just ignore it. He's the only one that does that. The other 2, the slight bit of noise, they bark. I live in an apartment complex, so and people in the hallway, are either talking or making noise, and if that happens at 2 o'clock in the morning, well, my dogs sleep with me, so guess who gets up at 2 o'clock in the morning? Yep. But what are you gonna do? You love them.
Yeah, that's why we keep our dogs locked up, except for the one on my profile picture. He's really old, so he just sleeps on my bedroom floor. The other 2 we have to lock up or else they'll get out and start barking, wake up the whole neighborhood.
Yep. Are they pretty good in their crates as far as not barking?
Yeah, they just sleep.
Okay, well, it sounds like there aren't any more questions, so I will see the Monday folks a little later. I'll probably be there before 3. I'll try to get there by 2:30, and we can start a little early. This lab can go. This is a full lab today and Wednesday. There's a lot of glassware involved, and it's specialized glassware. It's not in your drawers, and it's also very expensive. It's a pretty cool lab though, but it's very involved, and so it can go later. So if any of you have time issues, be aware of that. You're going to be in groups of 4, 4 or 5, depending on how it lays out. So if you have to leave because of work or whatever, or family issues that come up, just make sure you have contact information. And you're going to be in the same group next week for making soap. So one person will have the distillate in their drawer. So make sure everyone knows that combination. Because if that person's not here next week, you have to get access to your distillate. Okay,
Sounds good.
does someone have a question?
No, I was just saying sounds good.
Okay. By the way, Kaylee, my granddaughter's named Kaylee.
It's a pretty common name, I've heard.
Yeah, it's not spelled the same way as yours. Hers is Ley.
Yeah, I've only met one with they spelled like Leigh or something like that.
Yeah, it's phonetic, not phonetically, orally. I think that's the right word I would say. Kaylee is common. The spellings all differ though. In fact, Kaylee is going. My granddaughter is going to Sierra, except I teach Friday, Saturday at Sierra, and she's there Monday through Thursday, so we never meet. So, all right, you guys, take it easy. I'll see you a little later. And Wednesday, folks, I'll see you on Zoom. Now, starting on Wednesday, we're going to be reviewing this unit. So probably, so Wednesday will probably be an aldehyde ketone review, and then next week will be the carb review.